Assalamualaikum and good morning to Ms. Nurhaiza Yaakob. My name is Nurpati Habibti Muhammad Effendi, and today I want to present about my case study experiment. So my title for this experiment is Simple Pendulum Harmonic. So there are two objectives for this experiment. The first one is to determine the acceleration due to the gravity using a simple pendulum, and the second one is to investigate the effect of large amplitude oscillations. There's a little bit theory about this experiment. The oscillation of simple pendulum is a simple harmonic motion if the bulk of pendulum is a point mass, 3 is having a negligible mass, and the amplitude of oscillation is small. From the theory of simple harmonic motion, the period of oscillation of a simple pendulum is given by the equation 5.1, where t equal to 2 pi square root L per g, where the L is length of pendulum and the g is acceleration due to the gravity. So there are several apparatus used in this experiment. So the first one is a thread, second one is pendulum, scissor, ruler, timer or stopwatch, protector, and the last one is 2 chairs. So let's take a look at the procedure of the experiment. So the first step is the length of the pendulum was measured. So the first experiment we will use for 25 centimeter or 0.25 meter. The second one is the all apparatus was set up. So first of all, the ruler was put on the 2 chairs, and then put the pendulum on the ruler. The third step, the pendulum was released at least less than 10 degrees from the vertical in one plane, and the time for 20 oscillation was measured. For step 4, the operations was repeated and the average value was calculated. Then the period of oscillations of the pendulum was calculated. For step 5, step 3 and step 4 was repeated for at least 5 times with different values of length of the pendulum. The values for L and T were recorded. Step 6, a graph of T2 against L was plotted and the value of G was determined from the graph. And for step 7, the length of the pendulum was fixed at 100 cm. So the pendulum was released through a large arc about 70 degrees from the vertical. The time for 5 oscillations were recorded. The operation has repeated and the average value was calculated. The period of the oscillations of the sample pendulum was calculated. Next, for step 8, the acceleration due to the gravity was calculated using equation 5.1, which is provided in the theory, and use the value of L and T. For step 9, the values of G obtained from step 6 and step 8 was compared. So the question is, does the results different from the standard value? So the comments were given. For step 10, 4 uncertainty or limitations of the procedure in this experiment were described, and 4 improvements that could be made to this experiment were described in step 11. Use of other apparatus or different procedures may be suggested. So now we move to the observations and measurements. So the first table is first experiment, which is 20 complete oscillations with different length and angle less than 10 degrees. So there are 6 readings. Start with 0.25, 0.5, 0.75, 1 meter, 1.25 meter, and the last one is 1.5 meter. And each reading have 3 repeated experiment, which is T1, T2, and T3. So second table shows the second experiment, which is a 5 complete oscillation at length 1 meter or 100 centimeter and angle 70 degrees. So this table only have one reading, which is 1 meter, and have 3 repeated experiment, T1, T2, and T3. And the three table other than that is for the analysis for the experiment, which we calculate the time average, time for one oscillation, and T2. So let's move to the processing and analysis. So this is the table for analysis for experiment 1, where we calculate the time average, time for one oscillation, and T2. So the time average we get when we calculate total T1, T2, and T3, and then divide by 3. And then we calculate the time for one oscillation and square it for T2. So this graph showed between T2 against length for experiment 1, and it shows that the 3 points hit each other for a straight line and 3 points missed, and the gradient was calculated based on the graph. So based on the graph, the gradient is 4, and when we put the gradient into the equations given, the value of G is 9.88 ms-1. And for experiment 2, for step 8, when we put in the equations, the value of G is 1.58 ms-1. So let's move to the results and discussion. So this is the comparison value G in step 6 and step 8. So based on the data, the acceleration of the gravity is 1.58 ms-2, while from the graphical method, the value determined is 9.88 -2 ms-2. So this is showed that compared to the standard value of gravity, which is 9.81 ms-2, the gradient from the graphical method is more near or similar to it. So the value of the acceleration of gravity is more far than the standard value of gravity. This may be because the graphical method is more reliable value of the gravity than the theory of simple harmonic motion due to availability of the gradient in the formula given. Furthermore, the value of acceleration due to gravity is not constant at all places on the surface of the Earth. Since the radius of the Earth is minimum at the poles and maximum at the equator, the value of G is at maximum at the poles and minimum at the equator. So this is the limitations and improvements for this experiment. The first one is the surrounding air resists the rate of swinging of the pendulum and causes errors in the value of the period. To improve these limitations, switch off the fans and close the windows to reduce air resistance. If possible, use windshield to reduce the amount of air resistance on the oscillations of the pendulum. The second one, the protector might be too small as it is on the phone, which can lead to parallax error while taking the reading, which causing fatal in reading. To improve, use the bigger protector to get more accurate reading and to minimize the parallax error while taking the reading. The third one is the reaction error by the stopwatch. So as this sustains repeated use or age with service life, stopwatch can become less accurate and give error in time records. And to improve, to calibrate the stopwatch properly. So as the last but not least, a parallax error also can occur when the observer's eyes is not perpendicular with the rulers when measure the length of the pendulum. So to overcome these limitations, the observer's eyes must be perpendicular with the meter rulers when taking the measurement of the length of the pendulum. So as the conclusion, to sum up, the objectives of this experiment were achieved. The acceleration due to the gravity using a simple pendulum was achieved, and the effect of large amplitude oscillations was investigated. To conclude, increasing the amplitude oscillations means that there is a larger distance to travel, but the restoring force also increases, which proportionally increases the acceleration. So that's all for me. Thank you.